Hi, this is Mr. Campbell. This is Algebra 2, Topic 0, Day 2, and then I will do all the parts, and then I'll Day 2 because it's 3 days, and it's what covered Day 2. So I'm going to do it all at once, and then I'll mark on notes and also in the folders and use each day students. Day, all of them together, and I'll put down the Schoology time where each one stands for you, okay? So, questions to think about. First is, how many real numbers can you think most, okay, most. So first, we're going to create a model, which is, will be x is less than or equal to 10. Most 10, it can be 10, it can equal to 10, just can be bigger. So here's your inequality. And then if I go to graph it on the number line, we like to put 0 on the number line, so relative to where 10 is on the number line, hopefully you know what it should be. And of course, when it's got an equal sign, we always have a clear circle, and of course, all the numbers on this one. Okay? That says how many real numbers are between -2 and 5. This one up here, because it goes to the left and never stops, is called an unbounded solution. This one here, because of these e-flights, will be a bounded solution. So when we do this one here is going to look like, and it says, and I want you to change this on the note to -2 and less than or equal to, okay? We're going to do that. So now rough my you would do left to right, so -2 is to the left of that. So -2 is less than x, which is less than or equal to. -2, so I'm going to include it, which means it's not an equal sign. And 5 is equal to, it is included. Included means it's part of the solution, not included means it's not part of the solution. So that's kind of this media. There's 0, -2, 5. So then we have open circle at -2 is not included, and 5 is a closed circle because it is included. Okay? The next one says, how many real numbers are more than 3? Or, it's a key word, or less than 0. So, always write from left to right. So 0 is to the left of 3, so less than 0 is going to be right here. It's going to be to the left of 3, so we're going to put it here. Oops, and so it's 0. Okay? And it's a 4 because these are in opposite directions. 4 is greater than 3. Okay? So when we go to put that on the number line, 0 here. Of course, our both do not have equal signs, so both includes open circle, and then opposite directions. Usually we do that, they'll go in opposite directions. So we use that or symbol to connect those two. Okay? Another way to express another way to express our answers is using interval notation. And interval notation, a pair of values that describe the minimum and maximum values of the solution using brackets or parentheses and the infinity sign. And you always look left to right. So like this one here says brackets 3 to 4, all numbers are greater than 3 and less than 4. So if we get them in the numerator, let's put in, okay, then we look down 3, here 3, since it's equal to the closed circle, and less than or equal to 4, or this will be a closed circle. You can use them. You would like to run your notations. The other notation would be 3 including closed circle. It's a closed circle in these brackets, and the other point is 4 is instantaneous. Just it's a closed circle, so it's open circle parentheses, closed circle, it's infinities notably with parentheses. Okay, so the new thing, all numbers are greater than 3 and less than or equal to 3. So this one here, so we have 0, 3, 4, and then so the number are greater than 3, so we didn't make it so it's equal, so we put on this and equal 4, so it's going to be closer. So this time, the notation look like this. Same interval, except 3 has a parenthesis because it's an open circle, and 4 has a bracket because it has a closed circle. These are equal significant on the data you see. After the next one is all the numbers are greater than it's up to the greater than equal to 3. Over here, and greater than equal to 3, so it can be close simple, and for less simple is a open simple, not equal simple. So close open, notation. These close, so this is going to get, and closed open because it's parentheses. And the next thing is all values that are greater than 3 and less than 4, so equal so this time. They got some values in the notation. It's going to be both parentheses. Okay? Those are the values, which is another next thing with me. Notice, I'm just doing this with you. All the information will go to the show you. All numbers greater than or equal to 3. So there's 0, there's 3, greater than or equal to 3. So closed circle, because it says equal to, and it's going to be everything in this way. So you look left to right. Oh, I'm sorry. Okay, so this is this one out here. Okay? So greater than or equal to 3. That'd be some like the right farthest point is 3, so it's going to be a blanket. And then over here is positive infinity. If we're going negative infinities on this thing, since the arrow is pointing towards positive infinity, the solution. Notice infinity is always parentheses. And then the next one, this one here, overall numbers are more than equal, less than or equal to 3, and greater than 0, 3, so 1, it's not equal to 3, so it'll be closed circle again, and it's going to go this way. And on the negative infinities over here, positive infinity here, so this time it's pointed towards negative infinity, so that would be our left, and the right one would be 3 and 3. When you talk about overall numbers, when you graph it, all real numbers, of course, this is going to be a number, and this going to be and rows, and rows, and it's going to be everything going this way. In an interval notation, you will need to remind you to make negative infinity. Okay? Putting this together here. Notice 10. So it can be 10, it just can't be greater than 10. So that interval notation would be, if the most 10 be empty, it would be 0's here, 10's here, closed circle, and everything going this way. Okay? So that would be the left eliminate. Negative infinity over here, positive infinity over here. Since the arrow is pointing towards negative infinity, it would be negative infinity to 10, and since it's in closed circle, like this. Okay? Between -2 and 5, and putting in closed circle. So open circle -2, put it in closed circle, so it's got -2 and 5. So it will be, it's a non-solution, so it's -2. It's 20, it's 20%. And the 5 would be communicate because it's included. More than 3, that's the key word. We're going to have two different interval notations here, and you'll see when I use it, might do it. Okay. So more than 3, 0, 3. So more than 3 is going to be here going this way. It's not included, and less than 0 is going to be open circle going this way. Notice these are going in opposite directions. Therefore, so we write another notation, again, negative infinity is down here, positive infinity is down there, so we're going to go negative infinity to 0, non-included, because it's an open circle. You see, we're not connected, so that's why we use it. And on this sometimes, when I use it too, they make a limit like this. With me in Schoology, we just use it. But you need to understand that all those are connected with the units. Let's see what's 3 non-included to 5. These look like most of them. Okay. The next one is at least 10. At least 10. So it can't be smaller than 10, but it can be at least 10. So if we go to graph this thing, at least 10, so it's going to be, it can be 10, so it's going to be a closed circle, and then it's going to be everything like this. So then the interval notation with the weight would be 10, right? Because you're the select that, and then it's going to be towards 1. I'm not going to look at the infinity today. Minor will be positive infinity, left row will be negative. Negative infinity is the smallest number. It will always be below positive infinity will always be to 1. And then the next one is between -3 and 0. So here, -4 here, both of them do want to be equal signs, so because the circles, we're just doing this to carry value to make it numbers. Some of you might need to do this. Okay, I like to do it. Seems to fit. So we then need to be -4, parentheses to do both the circles becomes none included, and 0 is also non-included, so also have an incomplete close parentheses. Okay? let's take a look at your logical folding super equations and apply that to solving super inequalities. What would be the difference between just inequalities compared to the absolute equations? And remember, equations we were doing one solution and we set equal to 0. And we had absolutely set to a positive constant, we get a solution. And the third one was when minus absolute equation set equal to a negative constant, we got mu solution. So the difference here with inequalities, you're going to get everything instead of points. And we were solving equations, which was the first unit, you got points. And with inequalities, you're going to get that. Okay? So the first one, so the answer to this is that variables. Let's split up points. Intervals, so points. Points is only the principal equation. Now we're solving absolute inequalities. Okay? One of the things that I noticed in the notes, it doesn't show. For some reason, I put it in the notes here, but I'm going to show you. We do this on the separate notebook here. And I'm doing this is when you do this here. Is whenever you have you're going to have two groups of inequalities. The first one is when you have less than or you can have less than equal to is an and code. And means input C. And that is input value less than or equal to C. Of course, you can also have input value that's less than C. You can solve it for the okay? And when you write your two inequalities, you would write x is less than or equal to C, and x is greater than or equal to C. You put these two together because ands will be 7. You'll end up getting endpoints, which would be negative C, up to greater than or equal to, and negative C less than or equal to positive C. This for this one here, and so the same unit. X is less than C, and X is greater than negative C. And you put that together, you get negative C is less than X, which is less than C. The difference between the two, this one will make it side. Okay? And both conditions must be satisfied. Both of these conditions must be satisfied. Now, the next one, which this was an and code. Okay? The next one is an or, which is greater than, and same thing, greater than or equal to, equal to is an equal. And so it would look like this. Absolute value of x is greater than or equal to x. That's right, greater than or equal to C. So when you reach your two inequalities, if the opposite, if the x is greater than or equal to C, or x is less than negative C, less than or equal to negative C. Okay? And what I would probably do is I would flip these two around, because when you graph them in the middle line, this time it would be the other way like this. X is less than or equal to negative C, or x is greater than or equal to positive C. Okay? And we do over here at the same time, it's just one equal sign. So it's going to be x is less than negative C, or x is greater than positive C. Okay? On this one here, only when you deal with words, only one condition needs to be satisfied. It can be if they both are not equal. First example, 4x plus 5 is greater than 13. Notice if it's greater than, it's greater than or equal to, it is an alternative. If it's less than, or less than or equal to, it is a down. Okay? Notice this one here is greater than 13, so this is going to, so we're going to run it for two inequalities. Okay? So the first one is root x plus 5 is less than negative 13, or 4x plus 5 is greater than positive 13. We're going to solve those each separately, okay? When it's first 5, you get 4x is less than negative 18, and both sides get 4, so I get x is less than or equal to, when you reduce it, I do not measure any values against it. Laser one for one down here, and listen here for 5, 4, and x is greater than 2. Okay, so let's do it this time. So, equal negative 4.5 and 2. Okay, so it was less than negative 4.5, so it's going to be here, and we're going to be this way. Here's where this direction is going to be. And 2 is 1 going this way. Okay, so now let's do a notation. So that's going to be a notation. I'll do with left and right. We do the fingers down here. So the notation would be negative infinity 4.5 when included, or 2 when included, inclusions open circle between parentheses to positive infinity. Okay? For the next one, here's an answer. It's an okay, and know it's an because it's less than after the need to really solve absolute equations, this absolute value has to be the same. So the first thing I'm going to do is divide those things into. Okay? So one equal to 2 is that gives me absolute value 1/x minus 10 is less than or equal to 1. So going to sacrifice it. That makes distance from 0. Since this is less than or equal to 2, we're going to write are two inequalities. Okay? The first one of these would be 1/2 x minus 10 is greater than -4, or 1/2 x minus 10 is less than or equal to positive. Those are two inequalities. And this is not an inequality, is it? Understand. This is an angle. Why? Because this is a center. Okay? A center equal to. So 110. You get 6. And then I'm going to multiply both sides by 1. It's simply multiplying the reciprocal. So okay? And, okay? I'm going to add 10 to both sides. I get 1/2 x is less than or equal to 15. Multiply both sides by 2. I get 48. Okay? So let's put those on the 0, 12, 8. Okay, so if you'll notice in this one here, close circle, getting 3 times this time. This time here, close circle 12, x is greater than or equal to 12, so it's going this way. And then and that and x is less than 28, it's going so crazy. Good. Group those two. Okay? So where do they intersect? They intersect minus 2, so initial solution. Then here will be here. Right there. Okay? With the adversity. So now let's write up the rotation with the brackets, brackets, there's no variables in these solutions, so there's no infinity signs. Okay? And when you have an and, you would make this like this. It means the same thing as this. But it look like this. You only do that with an and, you don't do it with this. It's the same thing as this. I think it's easier when it's written like this because then you know it's going to be this type of notation. Okay? Remember, we always have to get the absolute value by itself. Okay? So I'm going to subtract 3. So then that gives me the absolute value of 2x plus 3 is less than 5. This is less than, so this tells me right now. Always get your absolute value by itself first. So now we're regulating two different inequalities. So negative 2x plus 3 is greater than -5. And negative 3x plus 3 is greater than +5. Those are two equations. And there's some new one to put because notice this process are going to get really short in the process if you're only we divide by negative. We're using negative, but we need to multiply both sides and move forward. You get the first one. So this gives me x is less than 3. So this is forward. Okay? So we're here for something. And we have an angle. So it's 23. We have 2x is greater than 2 divided by negative 2. So the x is less than negative 1. Okay? So let's get over here so we can 0, negative 1, 4. Okay. X is less than negative 1, so just click the circle, break. Now this way, so negative 1 and 4. We're clicking 4. X is less than or equal to 4, so it's going to be here on this one. Man, what you notice in this one here is x is less than negative 1. I made a mistake there somewhere because start over with this one because I made a mistake in looking between the folders. My apologies. Do this one again. So we have lots of value of negative 2x plus 3 plus this. So this is an and problem. So first thing we have to do is isolate the absent value. We always have to do that before we write our two base. This is an and problem. Okay. So we end up with 3 we need to play with. So now we write our two inequalities. So first one is negative 2x plus 3 is greater than negative 5, and negative 2x plus 3 is less than positive 5. We're going to inequalities. Okay? Sure we have them looking good. Okay. So this one here we're going to subtract 3. Divide by negative 2, and wherever divide by negative and inequality, both probably get to a less than inequality, so f is less than positive 4. Okay. Then an and here, subtract 3, we get negative 2x is less than 2, and I divide by negative 2, I get x is greater than negative 1, because I get first inequality. So now let's go with it. The number line. X is greater than negative 1. So we have an open circle with negative 1. Okay. X is a little negative 1 in this way. X is less than 4 that way, going this way. So in reality, our notation will be 0 not included to 4 not included. This one here you would have wrote like this and then equality. These two mean the same thing. Okay? There we see it. Now, it's ready for example A2. So now this is a 34 minutes. Okay, will be day 2. Okay? So example 4, remember, this is greater than or equal to 1,000. This is going to be we have to isolate them before we write the two inequalities. So that gives me x plus 1. Let's divide x plus 1 and 2 on 16. Okay? So, if you remove this thing here can either be positive or equal to 0. That's what absolute means. This is negative. Okay? So let's think. This absolute value can only be positive or 0. It's always going to be greater than negative 16. So this one here is the negative one. This one here is all real numbers. It's going to be everything in both dimensions. Okay? So if you remove all real numbers here like this, okay? Now example 5. Again, we're going to get this side isolated, so we're going to multiply both sides by 10. Dividing them into the same thing, multiplying the sides by reciprocal. So that gives me this right here. Let's see how 2x minus 1 is less than negative 25. Absolute value is either going to be positive or it can be 0. It's never going to equal it. And this one here, of course, is negative. Okay? This one here is no solution because absolute value can never be negative. So this one here is just no solution. No solution. What did I say? A positive review. Can't be smaller than a negative. No solution. Next example we have with me about okay. When you have it if you remove it, 0 can only be played. Let's say you do this. Let's say you load like this. This less than, so this is greater than or equal to negative 0 and 7x plus 3 is greater than or equal to positive 0. Okay? Down with the positive side, so it's the same thing as this. So I subtract 3. Divide by 7. Okay? X is greater than or equal to negative 3/7. And this one here is subtract 3. What do you notice we get here? So if it's x is greater, so if I put it on the negative line, and go x is greater would be a closed circle going this way, and the other one would be a closed circle at the same place going up. So this one here ends up on all real numbers. It's the entire thing. So your interval notation would be negative and positive. So let's do this next one here. Of course, we're going to get this was talking 7 to the amount. So let's get into a big home. So it's a fraction, okay? It's 3. So that's the value of x minus 9 is greater than -5. So this is greater than, which means this is the negative. Okay? So the negative one goes with less than, okay? And let's subtract that. This should be 0. Which you can subtract that 0. So our first one's going to be x minus 9 is less than -0, or greater than the absolute value of x minus 9 is greater than positive 0. So 9 over 1, of course, I get x is less than 9 over here. X is greater than, right? So good. Okay, so this one here, notice, is 0. So this one here is going to have an open circle less than this one. And it's really going to have an open circle median. So it's actually in the median except for median. Okay? So let's do a little notation for the solution. So we look left to right, it's going to be negative infinity to -1, negative infinity, and that or 1 positive infinity. What was the median line? Exact median. Okay? Last one, once we have a rule, see. So this is the sign, which means this is a macro. So if we just find this, that's what we do on the side is our reverse side from like on the derivatives. Or we can distribute in transactions. As if the first side, this is an eon problem, and then it is copied down. Just copy it down. Okay, so 9x over here, is that correct? I don't think I'll plug negative 2x. Let's just close the 2. Okay, so 9x over here, which gives me 11x minus 1 is greater than 1. And 1 over here, is 2, which gives me x is 2 11x, greater than 2. If we're here, I'm going to split 9x over here, which gives me 7x minus 1 is negative 1. Add to the other side, 0 will be negative 7. So when I divide by negative after the reverse inequality, so that x is greater than 0. So x is greater than 2 11ths. Here's 0. 2 11ths is in here. So x is greater than 0, okay, is going to be, this is an equal. This here's the quick. X is greater than 0 goes this way, and if x is greater than 2 11ths, also what you gotta look at is big and problems. Usually they share the same. You gotta really both. Okay, so notice this one here. They don't share these points down here. They share a really kind of 1 and 2 points. So we're going to take function to just be base from 2 11ths, and then your interval notation be 2 11ths. We have 2 homes besides. Then we'll start on, here's phase 3. So I'm going to do that as well. 3. Alright. So so your friend tells you to the how much money she has and says thank you. It's $50 give or take 15 years. What's the least and greatest amount of money she gave? Let's think the least would be between the 50 minus 15, so these would be 30. I think would be the least. The greatest would be 50 plus 15, which would be 65. So this is an answer, okay? Because it's somewhere between 35 and 65. Okay? Because you can have everything greater than or equal to 35, and x can be less than or equal to 65. So you're going to have $35 or more, but you're never going to get more than 65. So I can remake this as an absolute value equation, which would be x minus 50 absolute value is less than or equal to 15. Okay? So that's what we're going to be doing here when we look at the formulas. Okay? So this first one says a professional baseball player could win. I mean, if his not to be equal balance should weigh 5.12 ounces, but can weigh 0.0125 ounces more or less. Okay, so you can released, the thing would be 5.125 minus 0.0125 ounces, which would equal 5.1125 ounces. Your greatest amount would be 5.125 plus 0.01, which equals, using the calculator, that. So it's between these two included. So I'm using the value of minus 5.125 absolute value is less than or equal to 0.0125. That's how you write that absolute value. And your integral in these two sums would be 5.125 to 5.125. These are the examples of what we're going to do here. And this stuff's pretty easy. Okay? So these are the two equations we're going to use for problem. Equalize reveal versus instant. Equalize from actual minus the means of the strings is less than or equal to 5. That's a relative mean. Okay? So, first example. So, ideal piece of metal remaining. Ideal. Okay? Here, 2.50 amperes with a tolerance of 0.05 inches. Okay, here's the tolerance. So we can use this equation to write it. Now, make sure you don't know. So your equation is what we're going to use. So it's x minus, which is 1 to be, From your equation, here's our ideal. So x minus 2.50 x of value is less than or equal to your tolerance, which is 0.05 inches. Okay? So if I write them two equations, or two inequalities, excuse me, x minus 2.50 is greater than or equal to negative 0.05, and the next equation is x minus 2.50 is less than or equal to 0.05. Here's the inequality, here's your second. So when I solve these, I get x is greater than or equal to 2.50 to the other side. Notice 2.3. This one here, we did 2.5 at the other side. I get x is less than or equal to 2.55. So this one here is going to be, this inequality would be this. Okay. It's going to look like this. Okay. For example 2, thickness of matches and men's parallel bars of both ends of gymnastics must be between 7.5 and 8.25. Inclusive means they're included. The answer can be recorded. Is this information different from the one that we just read from? This time, we have 9 weeks of the universe. With the main equalities. So what we have to do is we have to find the means of things. So first to find the mean, okay, let's find out first. This is 7.5 plus 8.25 divided by 2. Remember the two squares. Then we get 7.87. So those are means of things. Okay? Then we need to find quality. So let's think about this. On the number here's our means of strength, which is not enough. So we need to go from 7.875 to the next one, which is 8.25. Right? Our mean for our smallest area was 7.5. So we need to find tolerance. So how can we find tolerance? You get that tolerance. We know the tolerance of between these two. We're the mean. We could subtract this from this, or we could subtract this from that. Either way. So I could take 8.25 minus the mean. Gives me 0.375. So I could take 7.87 plus 7.4 and we get the same thing. So the equation is x minus the 7.875 absolute value is less than or equal to tolerance records. CV.37. Okay. So, screw rod produce a factor must be 10 inches long for the tolerant 0.2 inches. Steel rods that move within tolerant lengths must be 10 watt. Which of the following inequalities can be used to exercise which steel rods are tolerant? Which represents the length of them. Okay? So, then, we really think it could be would be 10 inches. So we know it's going to be x minus 10 inches. This is from, and it's going to be less than or equal to, which our tolerance is 0.2 inches. Those are the you're always going to have a means. Over here, mean right there. Close your clothes. This is always going to be the center of the picture. Okay? So we're going to be written on the wall. So which one is it? Looks like to me it's C. Okay? I think that's it. It's probably third review, so that would be the third assignment we need to. Okay? So again, I'm going to do this in class, and here's a video to help you. I'm going to put my answer in the Schoology, what times in the range police we did. Thank you.